Hello, everyone. And thank you, Professor Godfrey, for the introduction. So as Professor Samuel stated at the beginning, we always, and we still have the problem of the availability and especially accessibility of data in order to supplement any risk analysis approach or endeavor. So we will be presenting to you today and discussing an approach that we are suggesting in order to perform a data mining on different kinds of data. So data mining on different kinds of data in order to help to sustain all these analyses and studies that we want to do. So the outline of my presentation, I will start with a brief introduction, re-highlighting the importance of data availability for food risk analysis. We will state the current situation in the Arab region. We will try to discuss in details the proposed methodology through the data mining approach, and we will go for some conclusions, short-term, medium-term, and future perspectives. So, as we all know, and as we've been discussing from early morning today, food analysis is a key component in the healthy function and performance of the food control system, and sound decision-making relies upon the availability of and accessibility and accuracy of scientific data to inform the risk analysis, which is the foundation for establishing responsible regulatory measures. The investment in data availability also to support food regulatory measures is one of the key elements of the GFoRSS mandate and mission. In fact, last September, we had a meeting, a colloquium, which was held here also in Dubai for 3 days, and which was attended by 67 participants in person from 12 Arab countries from the region, and virtually by 120 attendees. In fact, during this workshop, the question of data availability and accessibility was raised at different levels and several times. In fact, one of the aims of this Codex meeting was to enhance Codex capacity in the Arab region through the development of enablers to Codex work, such as availability and accessibility of data information sharing and coordination. And during the discussions, all the attendees highlighted that a major challenge is facing the region, which is related to the access to these occurrence data, so that competent authorities can prepare their national positions for upcoming discussions. And one of the main recommendations of this meeting was to prioritize the priority areas of investment to support Codex capacities in the region is to ensure availability of data from the region and any needed technical tool also, which allow to help the coordination and the sharing of data. So in order to answer these recommendations, and under the framework of the so-called MENA Codex Initiative, which is now called the Arab Codex Initiative, we suggested the following methodologies. In fact, the project aims, or with the project we launched, aims to make data available and accessible for all Arab countries. So this data can come from 3 different levels: the published data, the unpublished data, and of course, eventually the data generation also. So how all these levels of data are interconnected? In fact, the easiest way to tackle this topic is to start with the published data. So that's what we are actually doing, and that's what I will be developing in the following slides. But also we are aiming to tackle some unpublished data also that we can find in different control laboratories, research institutes, chambers of commerce, industry and agriculture. And at the same time, we are targeting this reciprocal interaction or relation between the published and unpublished data and the data generation. So in fact, we are tackling this topic by data mining in order to fill the gaps. But at the same time, after our data mining, we will be able to highlight gaps also in data. So we have this interrelation So through this project, through this action, we will also be able to specify, to highlight some data gaps in order to orient, in order to target new data generation through reference laboratories at national and regional levels, through the generation of, through research projects by universities and other kinds of data generation endeavors. So, as I mentioned, the first step, or the easiest step to start with, was to go for the already published scientific data from the region. So, this is the methodology we are actually developing and we are actually dealing with. It consists of a data mining approach of published data, starting with a systematic scanning of the major scientific search engines and databases online, followed by data extraction and retrieval, and finally, putting this data accessible through an online portal, which will help to access this data, which will help also to coordinate, which will help us also to perform statistical data treatments and more performed and advanced data treatments. If we go to the first step, so our approach, as usual, when we do data mining, starts with a systematic scanning of major scientific search engines and databases. So we start normally by the topic selection. Then we will go to the establishment of the pool of articles related to the topic using well-constructed research queries. Then we will start with research engines normally, like Web of Science, let's say, but also we will be scanning again the different scientific and well-known databases like Science Direct, like Taylor and Francis, Springer, Wiley Online Library, etc. Then we will be using a reference manager in order to pool, to organize, to collect, to amend the different references that we have. And of course, now comes our job as a team performing this data mining to start by some exclusion and inclusion criteria based on different criteria and different levels, among which I can cite the quality of the published paper from different perspectives, the journal, the publisher, the analytical quality of the data published, relying on different analytical parameters and factors, which we'll be discussing in a few slides. Then, after pooling all this data and organizing the data in our reference manager, effectively, we will be doing the data retrieval or extraction. So we start normally by all data related to the reference itself, the journal, the publisher, the impact factor and quartile of the journal, the publishing year, the country, the region, which is mainly Arab countries, which are mainly Arab countries. Then we will be retrieving data related to contaminants, and afterwards, I will be specifying and discussing also why we chose to start with two particular contaminant families, which are the heavy metals, mainly lead and cadmium, and the mycotoxins, which are mainly aflatoxins, the family of aflatoxins, and aflatoxin A. But of course, we'll be tackling all different kinds and families of food contaminants. Then we extract all information related to the food commodity analyzed in this paper. The food group, the food identifier, the food code based on the WHO classification that we would like, of course, to amend in response to particularities related to the Arab region, the food origin, the state of the food analyzed. So all this data normally is extracted, retrieved from the papers. Then we extract also information related to the study scheme. What is the objective of the study? So normally we try to summarize the objective of the study. What is the adopted sampling plan during the study? Anything related to the sampling plan in details. Then we go for the analytical method, the sample preparation, the determination technique adopted, and of course, all parameters related to the analytical quality assurance of the used technique in this article or in that published paper. Such as, of course, the limit of detections, the limit of quantifications, the recoveries, indicating the accuracy of the method, all different relative standard deviations, related to precisions, repeatability precisions, reproducibility precisions. So all different levels of analytical quality assurance are retrieved. So after dealing with the analytical quality assurance, which also constitute a very important parameter for our inclusion or exclusion criteria of the corresponding paper, we go for the main needed information, which is the occurrence, the levels, the concentration of the contaminants found in different food commodities. So mainly, we are retrieving ranges of concentrations, minimum concentration, maximum concentration levels, and if we have access to the average and median, we are retrieving it. If we don't, if we have access to the raw data also in the paper, we are calculating it as the average and the median. And one more important information, the number of samples which were found to be below the limit of detection, if we have this information stated in the paper. So if I go back, the first step was to collect all different articles since we are working on published data. After retrieving all this information, the second step is to extract, to start the data mining. So we are extracting all these information. Then we start classifying, organizing all this information into Excel sheet. And here I'm giving you an example of the job we are actually doing. So normally we are tagging the paper we are dealing with, and we start extracting the year of publication, the country, the contaminant or contaminants, the food group analyzed, the food identifier, the food code, the food origin, state, etc. Then the study objective, sampling plan, all parameters and factors related to the analytical quality assurance and the analytical method, and of course the concentration, minimum range, maximum range, if we have access to the average and to the median, precision, accuracy, different units adopted. So the main thing is that in articles mainly, we can normally we analyze one or different food commodities, but also one or different food contaminants at the same time. So effectively, the main action that we are doing is to transform all this data into data points based on contaminant and on food identifier. So let's say we have 5 food groups analyzed, and for each one we analyzed 5 different contaminants. So we will have 25 rows. We will have 25 data points. So we are trying to go as much as in details as we can by contaminant, by food commodity, and even if we have the same food group and different food identifiers, let's say dairy and dairy products, but then we have cheese, we have fermented milk, etc. So we will be dividing also based on the food identifier. So mainly one article with few contaminants, few food commodities will be transformed into, let's say, 20, 50, 60 rows or data points. So in order to deliver to the Arab region as much as possible detailed information about this published data. And then after pooling all these articles and all these information, okay, so normally we go for, our aim is to go for an online portal in order to gather all this information and makes it accessible to all Arab countries and everyone freely. Okay, great. So I have control. So our aim now, and this is what we are actually doing, is to start uploading all this data information into an online portal. So our online portal will consist of a website, possibly also an app, transformed to an app, accessible to everyone. And we will have, when we connect, of course, we will have accounts to be created, logins, passwords. We will have admin permissions, normal or classical also logins and passwords. And then normally when we'll be collecting, we will be searching based on different search criteria. The country, we can search by country, and at the same time by a contaminant, by a food category, by a food identifier, precisely the food name itself, and by the date. So let's say we want to have an information about the occurrence of lead in milk and dairy products, specifically in milk, let's say, or in other cereals, or any kind of other food identifiers or group. We can have access to all this information by Arab country or for all Arab countries. And our purpose and aim is also to push further this database for further statistical data treatments and even more complex multivariate data treatments in order to generate reports, in order to make this kind of information more visual, more accessible, more easy to understand and to tackle for all Arab regions. In fact, our aim is to go through this approach on a country basis, effectively. So we will be tackling all different Arab countries, all different Arab countries. So we'll take it on a country basis. Let's say we started by Lebanon, we started by Egypt or other Arab country. We will take this country. We will try to retrieve all articles published on this topic. Let's say the heavy metals topic that we will be dealing with. And then we will go for another country in order to cover all the Arab region. Now, the starting point of this project was with heavy metals and specifically lead and cadmium. But effectively, we are retrieving information related to all heavy metals analyzed in the papers. But we are particularly interested in lead and cadmium. And also, the second step will deal with total aflatoxins and ochratoxin A. And why is that? Because, as I stated at the beginning, our initiative is to support Codex activities in the region, to support Arab countries in order to prepare their opinions, their national positions for Codex, for different topics discussed by Codex. And if we go to the last Codex season or the last Codex agenda or commission meeting, we can highlight different agenda items related to cadmium, to lead mainly, let's say maximum limit for cadmium in cocoa powder containing or declaring 100% total cocoa solids, which is still an ongoing work. Developing a code of practice for the prevention and reduction of cadmium contamination in cocoa beans. A lot of work will have to be performed on lead, draft maximum limits for lead in various food categories and the various food commodities. So we chose to start this endeavor, to start this work on cadmium and lead mainly in order to put this information, this data for the Arab region in order to help everyone to prepare their positions and to prepare their comments regarding these topics. At the same time, related to mycotoxins, we can see different agenda items also and still ongoing works related to maximum levels for aflatoxins in certain cereals and cereal-based products, maximum levels of total aflatoxins, ochratoxin A, and different food commodities. So as a conclusion, the Arab region needs more accessible data to support food regulatory decision and to prepare for Codex discussions and position taking. GFoRSS will actively contribute to make data available and accessible as much as possible through its Arab Codex initiative and the portal we are developing now. The data mining will tackle different kinds of new contaminants in the future of an interest for the region, of course. And this data mining project will also help to highlight gaps, as I stated at the beginning. We will also be able to highlight gaps in data in order to so regulatory control, research funding, universities can be oriented towards addressing these topics in future works. So at the end, I would like to thank Professor Godefroy for his trust first. I would like also to thank Mrs. Joyce Haddad, which is my team member and my colleague in this project. And thank you all for your listening and for your attention. Thank you.